Millikan's oil drop experiment. The charge of an electron was determined by Robert Millikan using Millikan's oil drop experiment. The setup of Millikan's experiment shown consisted of two plates, which are positively charged plate and negatively charged plate. These two charged plates are in turn connected to a battery. An atomizer, a device used to emit liquid as fine spray, along with microscope is arranged. The purpose of this microscope is to observe the movement of tiny oil droplets. In the Millikan's experiment, with the help of an atomizer, a fine spray of oil droplet is sprayed into the upper chamber. It is observed that most of the tiny oil droplets spread all over the surface, while few oil droplets moving with certain velocity enter into the lower compartment under the influence of gravitational force. By observing the movement of tiny oil droplets, Millikan was able to calculate the mass of an electron. Now, X-rays from an external source are made to pass through tiny oil droplets. These energetic X-rays falling on oil droplets removes electron from the oil droplets and makes them ionized. The negatively charged electrons lost from the oil droplets due to ionization clings or gets attached to the oil droplets as shown, which makes these oil droplets negatively charged. The velocity of oil droplet could be controlled by changing the voltage across two plates. At high voltage, the negatively charged oil droplet tends to move upwards or rise towards the positively charged plate. This is because the electric force, which is the product of charge and electric field or oil droplet or QE, which is pointing upwards, is greater than the gravitational force mg acting in the downward direction. At a particular voltage, the oil droplets suspend in air. At this point, the weight of oil droplet, which is the product of mass and acceleration due to gravity, or mg, equals to the electrical force acting on the oil droplet, which is nothing but the product of charge and electric field, or QE. By moving E term to the other side of the equation, we get charge on oil droplet Q equivalent to mg divided by E. Millikan has found out that electrical charge on oil droplets was equal to the integral multiple values of negative 1.602 into 10 to the power of 19 coulombs. That is Q equals to Ne. Here Q refers to the charge, while n is the integer which takes values 1 to 4. From this experiment, Robert Millikan has concluded that this fundamental unit of charge on one oil droplet, which equals to the value 1 into minus 1.602 into 10 to the power of minus 19 coulombs, or minus 1.602 into 10 to the power of 19 coulombs. This is nothing but the charge of electron. Using the charge of electron value of minus 1.602 into 10 to the power of minus 19 coulombs and J.J. Thomson's charge to mass ratio of electron, that is E by m value of 1.76 into 10 to the power of minus 11 coulombs per kg, Millikan has calculated the mass of electron. On substituting these values in the equation E divided by E by m, we get minus 1.602 into 10 to the power of minus 19 divided by the value 1.76 into 10 to the power of 11. This equation, on further calculation, the mass of electron was found to have a value of 9.11 into 10 to the power of minus 31 kilograms. It was also found that the mass of electron was about 1836 times lighter than the mass of hydrogen atom, as shown by the equation.